Firstly, good afternoon, ladies and gentlemen, and welcome to the first session of the Focus Symposium. A symposium sponsored by the EDGAR Centre, the Healthier Lives National Science Challenge, and the Riddet Institute's National Centre of Research Excellence. In this session this afternoon, it will consist of 6 presentations, and the focus this afternoon is on fibre and the relationship between fibre and non-communicable diseases. I think this is very timely because, to a large extent, fibre has been the neglected dietary component. And so often, nutritionists and scientists carelessly talk about dietary carbohydrates as a collective, making no distinction between those carbohydrates giving rise predominantly to glucose, and on the other hand, the non-starch polysaccharides that are partially fermented in the GIT. Such fermentation, of course, gives rise to the volatile fatty acids, and they have very significant nutritional and, I think, increasingly being understood and discovered physiological roles. I'm sure we'll hear more about that from John this afternoon. I think the session is also topical in that the gut microbiota, which is fuelled by those non-starch polysaccharides, is very much in vogue in terms of international science. It's a great pleasure, Jim, to chair this session and to be part of the symposium, which has been arranged in part to mark the visit to New Zealand of Dr. John Cummings, and also, as mentioned by Professor Beaglehole, to honour the lifelong contributions to nutrition and medicine of Professor Jim Mann. Both men have made, and I underscore here, and are still making, very substantial contributions to their fields, and are standout leaders in contemporary nutritional science. I would like to take this opportunity to salute both of them for their very significant contributions to science and to nutritional science in particular. I'd also like to pay a personal thank you to Jim for his support and collaboration of my own work over many, many years. Ladies and gentlemen, without further ado, it is my great pleasure to introduce our first speaker for this session, Professor John Cummings from the University of Dundee. John is one of the most distinguished gastroenterologists in the United Kingdom and has made important contributions to our understanding of the anaerobic metabolism of carbohydrates in the large bowel. He has been Professor of Experimental Gastroenterology at the University of Dundee, and previous to that was head of the gastroenterology group at the MRC Dunn in Cambridge. He is a real authority, he is the authority on fibre and health. Ladies and gentlemen, Dr. John Cummings.
Thank you. I always enjoy coming to New Zealand, but this is the first time I've been on the mainland, as I'm led to believe it is. But so far I've had a very, very good time indeed. But it is a great privilege for me to be here in the presence of such distinguished people in the world of nutrition and public health, particularly Professor Beaglehole, who I've met for the first time today, but who has been a pioneer in public health nutrition over many, many years. And we should not forget that Professor Stuart Truswell is here, who has brought nutrition to the world community over many years and backed it with good science. And it's good to meet you again, Stuart. And of course, Jim, my very long-standing friend. Note, I didn't use the word old friend. But I'm never quite sure what Jim's ever done, but he's had plenty of praise today, so we'll leave it at that. My job is fibre, but I'm a gastroenterologist, so I take it from that point of view. And I'm going to, since I'm a wholly incompetent scientist these days, I'm going to start with history and give you some background as to how the ideas about fibre evolved, and then later on today, look at some of the physiology. So, I've also been asked to say this, people would not take photographs of the slides and put them immediately on Twitter. That would be very good. Right, okay, actually this is an important year for fibre because, as I will shortly tell you, it does mark an important 50th anniversary in its history. But the story for fibre goes back a lot longer than that. In fact, it goes back at least 200 years. And this is from Piet van Soest's book on the ecology of the ruminant. And you will see, if I can get this going. Yeah, more or less, yeah. You will see that there were German chemists working on the measurement of dietary fibre over 200 years ago. Why were they doing that? They were interested in animal nutrition. And fibre was considered to be a factor in the diet of ruminants particularly, which impaired the nutritional quality of the feed. And so to know what the fibre content was very important in those days. What they measured was something called crude fibre. That's better. Something called crude fibre, which methodologically was not very good, but it served the purpose of the animal nutritionists. So there's a long history. And over the years, a number of people have been involved in the development of the fibre story, and this is a list of some of them. And we clearly don't have time to talk about all of them today, but at the top there are the German chemists who were interested in the inhibitory effects of fibre in the diet of ruminants. Rubner, number 3, he was the first person to do human feeding studies, again in Germany, and he fed different sorts of bread to groups of medical students. And then we came down to, a bit difficult this pointer, Allinson, the bread person, Rendell Short, McCarrison, and then McCants, who probably you've all heard of. And he made an important contribution, which will pick up on something that Professor Morn has just said. McCants was a nutritional physiologist and professor of experimental medicine in Cambridge. And he was a diabetic doctor and very interested in treatment and management of diabetes, which is, I think, is that the pre-insulin days, isn't it, Jim? 29, yeah. So it was very much about diet. And the Medical Research Council asked him to produce a guide to what sort of diets diabetics should be having. And he wrote this 80-page report for the MRC with Lawrence about the carbohydrates in food. And it's a very pioneering document, and if you ever work on fibre, you should start with this. Half of this document is about fibre. And you'll see it talks about fibre in nature, its role in nutrition, the different sorts of fibre, different breads, and other interesting things which we'll come to later on today. And he brought in the concept in this document of there being available and unavailable carbohydrate, and by which he meant some carbohydrates were glycemic and others were non-glycemic, as you said. Very important early distinction. And I don't need to explain to you which are the non-glycemic and which are the unavailable ones. The difficulty with the unavailable notion is that fibre is not unavailable at all. But that's 90 years later, and we can be a bit wise after the event. But so this was really pioneering stuff from McCants. And then after him, the Cowgill and Olmsted and people started working on the gut effects of fibre, particularly on its effects on bowel habit and digestibility. Walker will come to later. Hipsley, one of the unsung heroes of the fibre world. That's his name. He was an obstetrician. And he thought that you could prevent toxemia of pregnancy with fibre. This has never, ever been followed up, but the paper's very good. And he talks, the title of the paper is Dietary Fibre and Pregnancy Toxemia. And in the paper, he defines fibre for us, There's lignin, cellulose, and hemicelluloses, and if we'd stuck to that definition, we'd have been saved a lot of trouble at Codex and WHO and everything, because it's almost perfect. We can drop out the lignin and you've got it. And I've never ever heard anybody quote this or refer to it or anything. And toxemia of pregnancy is so common. So, Hipsley, I give him credit. And then David Southgate's coming more to the modern era. So the early history of fibre is animal feeds and digestibility, and then the benefits of wholemeal bread and the laxation effects in the gut. McCancy's concept of unavailable carbohydrate, and the more recent stuff on bowel habit, etc. Right, that's the early history. Now let's jump to this guy Burkitt. You all know about him. He's essential to the fibre story. He became known, he was Irish, trained as a surgeon at Trinity College, Dublin, and he entered the Colonial Medical Service as a surgeon in Africa. And he was best known for his work on a nasty tumor of children, a lymphoma, which eventually became known as Burkitt's lymphoma. But when he left Africa and came back to the UK, he gave his life to working on fibre, and he became known as the Fibre Man. He's the only fibre man we have. And this is a book written in 1985 about his work. So he's an interesting person, and how he got this name and how he got into fibre and the legacy he left us is what I want to talk about. But to understand Dennis, we need to know a bit about his family, and this gives me a chance to air one or two of my prejudices. This was his dad, James Burkitt. He worked in Enniskillen. He was the county engineer for one of the large counties in Ireland, Fermanagh. He was a very able man indeed and carried off every prize that you could possibly want. And it's of topical interest because this is a map of Ireland, and that blue line is the border. I'm sure you, and this is Brexit we're talking about now, and just make sure we get it on the agenda sometime today. And here is this border, which there is so much trouble about at the moment. And James, at the time of partition, in 1922, he was given the job of rerouting the roads and rebuilding the bridges so that people that lived in the north could travel around without having to go into the south. And it's a ridiculous idea, the whole thing. As you can see, just look at the border. Imagine trying to police that. So there are over 100 roads crossed even to this day. So James was an engineer. One of his tasks resonates today. But he was very used to having maps of roads and places and all this sort of thing. He was very familiar with maps. And he was also an amateur ornithologist. And he wasn't just any amateur ornithologist. He was described by David Lack, who was the professor of zoology in Oxford at one stage, as one of the seven most influential ornithologists in the world in the early part of this century. And what he did was he was very interested in the robin. And he had a large garden. This map has never been shown in public before. It's one of the reasons why I've got to be a bit careful. But he was interested in robins and how they defended territory and what they did at different times of the year in terms of breeding and all this sort of stuff. And he drew maps in his large garden of the territory of individual robins and watched them over the years, how long they lived. And he was the first person to suggest that their lifespan was something about 2 years, for example. And he drew these maps. They're hidden away in an archive, but I managed to find them. And they are highly significant, I think, for the fibre story, because Dennis, who in 1924 would have been 13, was brought up in a house where maps were part of everyday life. And you understood things by drawing maps of them. Dennis went to Africa after doing his army service and training and everything as a medical officer in the Colonial Medical Service. And he was posted to this place called Lira in Uganda, where he was the sole doctor for 250,000 people and had to do everything. Deliver the babies, do all the surgery, treat the earaches and the lot. And I would say he was not possibly entirely trained for all these aspects of his work, but he managed. And very soon after he arrived, he noticed that what he was operating on was a very great number each week of a particular condition which he hardly saw in the UK, which was known as hydrocele of the testis. It's a swelling of the male testis due to fluid. That Jim knows this, doesn't he? Yes. I mean, we very rarely saw it, did we, when we were young housemen? But Dennis found he was operating on 8 or 10 of these a week. And he got together, and this is Dennis's first paper in the Lancet, he got together a series of 200 or 300 cases that he'd operated on. And what he noticed was that the great majority came from the west part of the region he was working in, and very few from the east. And he drew a map of this. And this was his first map relating disease to geography. So primary hydrocele in his testis. The way he found the cases was he went out to the various tribal villages and got the chiefs to line up all the men there naked for him so he could examine to see who got hydroceles. I'm sorry I haven't got a picture of this for you, but... And in the paper, he wrote, sorry, I've gone back, I need to go back, don't I? Right. He writes that there's a huge geographical variation, 25% in the west, in the east and 1% in the west. And in the paper, he suggests that this is a climatic thing due to some insect vector causing the problem. He left Lyra after only 18 months, and he wasn't able to follow it up, but eventually it was shown that the mosquito carried the filaria, which caused the hydrocele. Right, he moves from Lyra to Kampala, to the medical school there, and the hospital in Malago. That was what it was like in 1948. And he became a more senior surgeon there. And this is what you might think is another diversion, but I'll tell you why this is important shortly. In Kampala, he worked hard for a number of years, and after about 10 years, this chap in the middle here, Hugh Trowell, took him to see a case on the pediatric ward and asked his opinion about it. And it was a case of a child, and this isn't the original case, but it was a case with a child who had swellings of its jaw. And this, as you can see, is already beginning to displace the teeth. And this was a cancer. Now, I've got another slide of this, and if you don't like nasty clinical slides, just look away for a minute. This is a few months later. This is the most rapidly growing cancer that there is today, and was in those days. And Dennis noticed that actually, he started looking for the cases, and he began to find them in the records and talk to his people in the various hospital stations, and he immediately noticed that it only came from certain areas of Uganda. And he began plotting them on a map. And he built up what was known as the Lymphoma Belt. He found 120 cases and wrote it up in a journal called Cancer in 1961, Malignant Lymphoma in African Children, with a very good pathologist called O'Connor from the States. And they realized, between the two of them, A, that it was a lymphoma, because there was some doubt about its histology originally, and secondly, that the distribution was so defined that there must be something in the environment that was causing it. And to define the environment exactly, Dennis went on a safari, which has become a legendary journey now, the long safari, and he did it to define the boundaries of where this tumor was occurring. And this is the route he drew on the map. Again, this has never been seen in public before. This is the route he drew on the map of Africa as to where he went on this 10,000-mile safari, which took him 10 weeks with some friends, visiting all the stations, hospital stations, and finding out what cases they had there. And it was so legendary that somebody wrote a book about it. And he discovered that there were very specific climatic conditions which led to this tumor. And he had a paper in Nature, and this recorded that the tumor only occurred where minimum temperature throughout the year never fell below 15, and there was always at least 20 inches of rainfall. And this coincided exactly with the distribution of the mosquito and malaria. And he was in England shortly at the same time as this, giving a talk at the Middlesex Hospital, and in the audience was a guy called Epstein, a virologist, who came up to him afterwards and said, "Could you give me some of your tumor, please, and I'll see what I can do with it." And to cut a long story short, this became known as Burkitt's lymphoma. Epstein found a virus in it, which became known as the Epstein-Barr virus, and it was the first virus associated with any cancer. So it was quite earth-shattering. And this came from Africa, from a man who was the most humble and would never claim to being an intellectual. And he was very proud to say he never wore a white coat and never went in a laboratory. But the tumor eventually became known as Burkitt's lymphoma. Why do we need to know about that today? Because things went pear-shaped in Uganda. They got independence, and it was very difficult, and he had to leave his job. And the MRC brought him back to England in 1966. But he came back to England with an absolutely amazing reputation as a scientist for having discovered this lymphoma. And his main tool in his armory was the geographical pathology of disease, which already had given him the clues about two major diseases. Right, let's bring somebody else into the picture, and then we go back to Dennis. This is a guy called Cleave, who some of you will have probably heard of, Thomas Latimer Cleave, a naval captain in the Navy, who traveled the world and observed that in some parts of the world diseases were common, and we're referring to the NCDs that Professor Beagleholz talked about, and in other places they were relatively rare. And he thought this was due to diet. And the thing in the diet he reckoned that it was the fact, and this is an article, the first article in '56 on the subject. He thought that in the diet we were interfering with our natural food by machinery and thereby refining our carbohydrates to produce refined starch and refined sugar. And it was the consumption of these which led to all the major problems that we saw. The article is terrible to read. It's 50 pages, and it goes all over the place. There's philosophy and everything in it. But this was his hypothesis. And it has lived on, of course, this. He continued to be interested in it, and he noticed from reading the British Medical Journal that there was a guy in South Africa called Campbell, G.D. Campbell, who I think people in here, some of the people here would have known. And Campbell was he came from a family that owned sugar plantations, and he was a diabetologist, and he was absolutely convinced that sugar caused diabetes. And he wrote to the BMJ letters, and he wrote articles on diabetes in the Zulu and all this sort of stuff. Quite good. And Cleave read these papers and got in touch with him and said, you know, I think we've got something in common here. And they wrote a book together. And this is the first issue of a famous book in nutritional history, Diabetes, Coronary Thrombosis, and the Saccharine Disease, by Cleave and Campbell in 1966. And in it, there is an early list of the fiber deficiency disorders. And here they are. Some of them are a bit weird, the B. coli infections, but we've got coronary thrombosis, diabetes, obesity, and colonic diseases here. The thing about this is that there is no mention of fiber anywhere in this book. And Cleave was never a fiber man. And when Dennis eventually told Cleave that actually it's all due to fiber, he was furious, and he wrote some really strong letters to Dennis saying, you're absolutely wrong. My theory is it's refined foods that are the key. Okay, Dennis, back in the UK, was introduced to Cleave by Richard Dole. And he met him on the 14th of September, 1967. So he came back in 1966. And I have to say, within 5 or 6 years, the fiber hypothesis was on the table, and Dennis was writing about it. So he meets Cleave, and sorry, that's going too fast. He talks to Cleave. Can we get back? We can't. Yes, we can. He talked to Cleave at length, and he was given his book. But to give Dennis credit, he didn't believe the sugar story. He didn't know what was the real cause of these diseases, but he was sure that Cleve wasn't right. But what Cleve did tell him, which was a fundamental principle, was that if you have several diseases which occur together in a community, they're likely to have the same cause. And if they don't occur in another community, then that gives you the clue as to what it is. So that was an important principle for Dennis. Okay, so how did fibre come into this? Well, another unsung hero, I think, is Neil Painter. And I think it was him probably put the idea of fibre into Dennis's head. He was a surgeon in London, and he went to, he'd never worked in Africa, and he didn't travel the world like the rest of these guys. And when he was doing his work for his MS thesis, he went to work in Oxford under somebody whom Jim knew very well, Sidney Truelove, very well-known gastroenterologist. And Sidney had access to a new technique which allowed you to measure pressure in the gut using open-ended manometry. And Sidney asked Neil to look at diverticular disease and see if he could find out anything about the pressures in the gut and did it in any way relate to normal pressures, etc. Now, diverticular disease, as you will probably know from this, I hope Dr. Schultz isn't here, because this is a very bad X-ray by modern standards, but it does show you that the circular muscle of the large bowel is greatly thickened and indents the bowel, seen in this barium X-ray. Look here, it's indenting it massively and narrowing the lumen of the bowel very considerably. So you've got narrowing of the bowel lumen, and you've got these pouches sticking out in various places, and these are the diverticula, and they become infected and give all the symptoms. So this was classic diverticular disease. And Neil did his studies, and he showed that there were high pressures in diverticular disease. And the treatment in those days for the pain was morphine. And he showed that if you gave morphine, the pressures went up. So it actually revolutionized the treatment of it, because morphine was banned from thereafter. But Painter put his thinking cap on and said, why is the lumen of the bowel so narrow? And he looked back in the literature and saw some animal studies looking at animal models of diverticular disease, and which showed that if the animals on the high fiber diet didn't get the diverticular disease. And this rang a bell for Neil. And in this paper, which he presented to the Royal College of Surgeons, he said quite clearly that he thought a bulky diet was the key to lessening the high pressures and segmentation which occurred in the large intestine. And he took this up very seriously and devoted a considerable amount of time to it, and in 1968 wrote this review in the British Medical Journal saying absolutely certainly he thought that fibre was the key thing to preventing diverticular disease. Dennis read the British Medical Journal, and when Neil was due to give a talk at the British Society of Gastroenterology in 1968, where there was a symposium. I've not been able to get the program for this because there is no archive of it, but I'm sure that Neil talked about diverticular disease, and I'm sure Dennis was talking as well. And the two met up afterwards, and somebody's poster gone for a bit. And Dennis said, can we get together? I'm very interested in this idea about dietary fibre. And a year or two later, when Hugh Trowell asked Dennis when he first got the idea that fibre might be important, Dennis says that it was meeting Painter, and at that stage there was a flash of understanding that you can't have refined carbohydrate without removing the fibre, and it's not the refined carbohydrate that's the problem, it's the absence of fibre. That's fundamentally important, because fibre has important properties in the gut and elsewhere, as we've heard about a bit today. And the crucial thing in thinking about this is that it's the presence of fibre which has its own being and importance. So that put the fibre idea into Dennis's mind, and he went to print straight away with it. And it's 50 years this year that marks the first paper by Dennis, or anybody really, has the hypothesis, the early fibre hypothesis in it. And what he talks about in this paper is this group of diseases, and he was a surgeon, so he was only interested in bowel diseases. Talks about these large bowel diseases all occurring together in certain populations, and he says quite clearly that the reason people get them is that the fiber's been removed from the diet, and that's the protective factor. So this is a 50th anniversary for those that like anniversaries. Right, but the fiber story is much bigger than this. How are we doing for time? Not too badly. The fiber story is much bigger than this. It has some of the major non-communicable diseases in it as well. How did they get into it? Well, we have to just look at a couple of other people to bring that into perspective. One was Alec Walker, a Glaswegian who went to work in South Africa. And he was very interested in nutrition and disease, and he worked on calcium requirements and lots of things like that. And in 1947, in response to concern in the government about the increasing uses of laxatives in the population, he wrote this paper in the South African Medical Journal saying it's all due to changes in food habits, the use of laxatives, and what people don't realize is that there are different forms of dietary fiber, and these have important effects on the gut. There was nothing really new in this because some of the early pioneers had worked on fiber in the gut, but this put fiber in Alec Walker's mind, and his main interest was, and Stuart may correct me after the meeting on this, he's the expert, Alec Walker's main interest was atheroma, arteriosclerosis and coronary heart disease. And he started a big study in South Africa, in Joburg, taking various population groups, Africans living in the rural areas, those that had migrated into Joburg, and the white South Africans living in Joburg. And he looked at their diets, at their cholesterol levels in their blood. And what he found was that fat intake was clearly crucial in determining cholesterol in the blood, and that the rural populations had very low cholesterols, and the whites with a high incidence of coronary disease had high cholesterols and high fat intakes. But the interesting thing was that the urbanized population that had come in from the rural communities didn't have anywhere near as high a cholesterol as they would have expected to be, based on the sort of fat intake they had. And Alec realized that these people also had a high fiber intake, and that this was protecting them from the atherosclerotic process. So into the fiber story came atherosclerosis. Hugh Trowell, the physician from Malaga Hospital in South Africa, he was famous for his work on kwashiorkor, and did some amazing work on, he didn't originally define the disease, but he was very close to it, and he did some very good work on managing it. He had to leave Africa quite suddenly in 1958 because his wife was very ill, came back to the UK, and he wrote a book called Non-Infective Disease in Africa, published in 1960. And this book contains a description of all the diseases which you didn't see in South Africa, in Uganda. Heart disease, diabetes, obesity, renal disease, and all these things. And he says, we never see these, but if you ever do, this is what they look like, and here's how you treat them. And he gives a list of the key diseases he thinks are in this group: heart disease, diabetes, thyrotoxic gallstones, etc. He doesn't mention fiber anywhere in his book, and he says that it was all due to post-weaning diets, but he did at least bring this group of diseases together in a particular way. Now, in 1970, we are now, Dennis and Hugh both went back to Kampala to talk at the 100th anniversary meeting of the birth of Sir Albert Cook, who was a pioneer and built the first hospital in Uganda, etc. And Dennis was talking, and everybody there expected him to talk about his lymphoma. Of course, he was world famous. And he stood up and talked about fiber. And people couldn't believe it. And afterwards, Hugh Trowell went up to him and said, my goodness, he said, I've got this group of diseases which you don't see in Africa. You've got this other group of diseases. I think they both go together, don't they? And indeed they did. The heart disease and the fibre and the diverticular disease and the bowel cancer all went together. And suddenly, they had the fibre hypothesis. So this is how it developed, and I'm nearly finished. He meets Cleve and is sure that it's not fibre, it's not sugar, but that if you have a group of diseases occurring together, look for a common cause. He meets Neil Painter and hears about the diverticular disease. He understands that, he's a surgeon, and Neil Painter says it's fibre. Dennis never understood what fibre was. For the whole of his life, he didn't know what it was. But that didn't matter. He gets a flash of inspiration that it's not the sugar, it's the fibre that's been removed. That's the key thing. He meets Walker and Trowell, who put the atheroma and the diabetes into the story. And like he always does, Dennis went straight into print in The Lancet with this in 1970, talking about how relationships give you a clue of causation. And here is the first really serious list of the fibre hypothesis diseases. So I'm going to finish with just a few slides now about what he did next. Is that okay? Right. Okay, so by 1970, only 4 or 5 years after he's got back from Africa, there is a hypothesis for dietary fibre. And Dennis, being a surgeon and not interested in heart disease and these things, they were for physicians who were always a bit sort of woolly, really. But he was a surgeon and he had already solved one cancer, lymphoma, and he says, I'll solve another one. I'll solve bowel cancer. And he started to do that using all the tools that he had used in the past. First of all, the epidemiology. And this is his substitute for a map of bowel cancer incidence, which he got from Richard Doll. He was very close to Richard Doll. Richard Doll gave him the age-standardized incidence of large bowel cancer in men for various parts of the world, which was, these data were only just becoming public in those days. And to my great surprise, New Zealand's not on it. And I know New Zealand had very high risks for bowel cancer, if I recall, when I was working on this in the old days. You should have been right up at the top. I don't know, perhaps the cancer registries weren't developed enough. Anyway, to Dennis's delight, there was huge differences regionally around the world in cancer incidence, and right down at the bottom was Kampala, which had a very good cancer registry. He said, okay, and give him credit for this, he said, I'll do some experimental work to try and establish what may be the cause. And he started by measuring stool weight. And he found that in the African villages, they passed huge quantities of stool, whereas in the English boarding school, they passed very little, and the African boarding school was in between. And he went then to do something else, which I'll come back to later on. He decided to measure transit time. Now, this is an amazing thing for him to do, but I think Walker put the idea into his head. And I think Walker said to him, if you have high fibre, things go through rapidly, and therefore you don't get carcinogens building up, et cetera, et cetera. So Dennis took these pellets, and there are lots of methods for doing it, but the simplest method is you give pellets on different days, gut transit time, the time taken from Marcus to go from mouth to anus, measure the stools, and from that you can calculate the time it takes to go through the gut. And here we are back with his boarding school children with transit times of 70, 80 hours, 3+ days, and that's exactly what you'd expect to find today, and the African villagers with 1 day. Huge differences. And this pleased Dennis enormously. And he produced a hypothesis for why people get bowel cancer. First of all, if your food has very little processing, that means it has adequate fibre and very little refined carbohydrate, he still pays lip service to Cleve a bit. He says there's very little contact between the stool and the mucosa because things go through rapidly and very little time for carcinogens to develop. But if your food is highly processed, the reverse happens and you get buildup of carcinogens. And this is a diagrammatic representation of his theory for bowel cancer. And my last slide is here. He published this only 10 years after the lymphoma paper. And here he is with his cancer paper, large bowel cancer paper, and in which he says, in amongst the text, the removal of fibre is a major causative factor. And I know Andrew's probably going to tell us whether that's true or not 50 years later. But we have to give credit to Dennis. He justifiably became the fibre man. The most advanced statistic in any paper he wrote was a mean, and he was very reluctant even to calculate that. So take heart, those of you who don't like statistics. What happened after 1971? The balloon went up, Fibre went into orbit, and we all came to New Zealand in 1982, as many will remember, Palmerston North, for a meeting on fibre in human and animal nutrition. And here are the people that attended that meeting. I recognize some of them, and you may recognize more. But Burkitt had a major responsibility in launching this. Can you see yourself, Stuart? Oh, you can, right. Next to Pete Van Soest. Oh, really? Oh, right. My goodness. Okay. Oh, it's your chin is covered, right. I'll remedy that if anybody ever asks me to talk again. Right, so there it is. Andrew's going to tell you where things are now, I'm sure. And later in the day, I'll talk about the physiology and why fibre is important. So thank you very much.